Hi everyone, welcome to this new video. Today I'm going to show you how you can use Casio GDC effectively for kinematics problems. So before we start kinematics problems in the GDC, I would like you to know about these key terms, which are displacement, change in position, and in calculus we represent as integral of velocity time graph. And if it is a velocity, then it is definitely speed with direction, and it is the rate of change of displacement. There is one more, which is acceleration, and it is known as change in the velocity over time. And in calculus we represent this as a rate of change of velocity. Or there is another connection between velocity and acceleration. Velocity is integral of acceleration using certain limits. When we say initially or initial time, we refer to time equals to 0. And when we say the object is at rest, then also we always mention that velocity is 0. Moving right or up, velocity direction will be positive, so it is above the x-axis. And if your object is moving left or down, then your velocity will be negative, which means your velocity graph will be below the x-axis. And if velocity and acceleration, they have a same sign, which means the object is speeding up and slowing down if they are opposite sign. Now, the most important thing for this topic today, it is the distance and displacement. So when you have equations of velocity time, right, velocity in terms of time, distance can be calculated from A to B. These are time intervals from A to B. So you can actually integrate the absolute value of velocity function. That is going to give you the distance. But if you have a displacement, then you don't need to consider the absolute value, because displacement is the final minus initial. So that's what we use. So SB minus SA. So let's get started with the first question. So here I have my first question, which is on the velocity time as well. So an object moves along a straight line. Its velocity is given by negative t power 3 plus 3.5 t square minus 2t plus 6 from 0 to 4. So the object is traveling from 0 to 4 seconds. The object first comes to rest at t equals to k. The graph is shown. This is really exam style question. Now first thing is find the displacement. So if you remember, displacement is the integral of velocity, and you can find out the final position minus initial position. And for velocity time graph, displacement or distance, they are actually this area. So when we have this positive area, which is generally in the positive direction, but this could also be covered because this is in the bottom, so it is in the negative direction. So let's see how we can solve this question for the first part. So what I'm going to do now, I'll go to my graph settings in my calculator. So just open the graph and enter this equation, negative x cube plus 3.5x square minus 2x plus 6. I have already entered. You can pause this video and enter this now. And once you have entered, come back. I hope you remember from last videos, if you are plotting any graph or using a graph feature, you need to master the window settings. Now for this question, if I click on F3, my x minima is negative 1.7, which I really don't need, because I need my graph should be from 0. So I can actually enter 0 here as x minima. Maxima, it is representing your time. So for how long you want to see the graph. In the graph given, it is for 4 seconds, but I'm okay with 6 or 7, because so that I can see what is happening after 4 seconds, just to get more idea about the direction or motion of the object. When you come to the y values, by standard it is -10 and 10. I think this is fine. So if we go back and click exit and draw it, yeah, so we can see pretty much everything about this function. If you want, you can definitely adjust your y values. So for example, let me just take here as 15 as the highest, so that it gives us better picture of the graph. Yes, so it does looks exactly same as we have in the question. So now as I have this graph on my question, what is my first part? Find the displacement from 0 to 1 seconds. So which means they're asking us to find in one direction how far the object has traveled. So for this, what you have to do, go to GSolve and use your F6 button here. Click on integral, which is F3. You can use the simple one, which is the first option. And when you have this option ready, do not use arrows or just trace the numbers. Better you enter the lowest limit. So the lowest limit for me is 0. So I'm gonna hit 0. Look, immediately that pop-up will come. So it will ask you enter the lower bound. I entered 0 already. The next is 1. So just 1. So you can see this is the area from 0 to 1 under velocity time graph. And it is above x-axis because my graph of velocity is above the x-axis for 0 to 1 second. So I can actually use this number 5.9166 as my displacement for my first part. I have the answers. You can verify as well. It is 71/12. So if you calculate 71/12, what do you get? 71/12. So you get 5.916666. That's what we obtained from our GDC. So this is correct. So that's what we got. Displacement from 0 to 1. This is without GDC. If you are looking at how to do without GDC, this is here how you can integrate and then substitute the upper and lower limits. Let's go for the next part. So if you read, it says, hence find the greatest speed reached by the object before it comes to the rest. So which means we need to know where it is coming at rest and then where it is greatest, right? There are two things. So if you see the graphs, so how to deal with part C now using GDC. So I'm going to open my GDC here. First of all, I will find out where my object is coming at rest. So for that, I need to click on GSolve and look for the roots because velocity must be 0 if it is at rest. So roots, okay, so there we go, 3.42. So which means our velocity should be higher or maximum at some point before 3.42, and which is obvious. So you just find out the maxima from here. So click on the maxima and here you go. So it is at x equals to 2, y equals to 8, which means at time equals to 2, at t equals to 2, the velocity is 8 meter per second, right? So that's what you can easily calculate from GDC. Alternatively, what you would have done, you need to differentiate because you have the expression for the acceleration, and once you have expression for acceleration, you can differentiate it, right? So acceleration and then differentiate it. Sorry, that differentiation is already done. Now equate to 0, right, where your acceleration is changing direction. So here it is go, t equals to 2 and t equals to 1/3. So these are the 2 points. 1/3 it's here where it is minima, and at 2 it is at maxima, and we can confirm it. So let me show you how you can verify your answers using GDC. What I'm going to do, I'm going to have a graph of acceleration, right? So click exit and as you can enter directly -3t² plus 7t minus 2 in terms of x, but let me tell you another method. So when you want to differentiate something and you want to see the graph of that differentiated function, you can click on option, click on calculate. So look for the first option here, d/dx, and here you don't need to enter the whole expression because your calculator will read what you entered in y1. So just click on first option, y, and then 1. And where you need that differentiation, if you are looking for a specific value, then you can enter that value, otherwise just enter x. I'm entering x because I need the expression, not only expression, the graph of the expression. So I'm going to click x and enter, and now you will see the graph of differentiation as well. Now how I want to make sure that what answers I got from my first part without even using acceleration, how I can confirm it is correct. So I'm going to go to GSolve and find the roots of acceleration graph. So click on roots. So this is highlighting first graph, but I have to select the second one. So just use the arrow. Yeah, it's been highlighted. Click enter. Here you go. So 0.33, which is 1/3, right? And next one is at 2. So what these points are communicating to us, that at 1/3 and 2, the acceleration is 0. That's where your velocity is changing its direction from minima to maxima or coming back, right? And that's what we could verify from the maxima value. So if you see the maxima for the first graph, so here you will see the 2 is the root of acceleration, but at the same time 2 is the turning point for my velocity where it has a maximum value. So that answer is done. So it is actually 8. So let's find out the next part as well so that we can quickly finish this. Now D part, find the greatest speed reached by the object for the interval 0 to 4, which means now they're not looking only from 0 to 3.4 something, means the time when it came to rest, but now overall. So as you can see, the graph is going up and then going down as well. So I'm sure this is the maxima, the highest velocity in a positive direction, but this could be also the maximum value but in the opposite direction. So what I'm going to do, I will find out the velocity at 4. So go to graph, and if you want you can delete the acceleration graph. So let me just delete it so that you can avoid the confusion. Delete, GSolve, and for y calculate, I need to calculate y value, velocity at time t, and then I will make its magnitude as positive. So I'm going to go to the y calculate at 4. Here you go. So at x equal to 4, your velocity is 10, but negative. Negative means in the opposite direction, but it is higher than 8, isn't it? So therefore we should consider the velocity at 4 as 10. The next part was write down the expression to represent distance traveled. So when you say distance traveled for the object when the speed is increasing, yay, so the speed is increasing. So you need to see where the speed is increasing and find out from there. So you can easily find out from this graph where your speed is increasing. So if you remember, I had a minima somewhere here at 1/3. After 1/3, my velocity was increasing to the maxima. Then my velocity started decreasing again, right? Then it is coming to rest, and after that it is again increasing till 4. So for that you can write down the expression. That's how you can find out. So 1/3 to 2, where your speed is increasing, right? So between these two values, this is 1/3, 0.33, that's the first one, and this is 2. So in this interval the velocity was increasing, or you can say the speed is increasing, and after that there is a certain point where k, because here the velocity was 0, right, because it was at rest, and after that it was increasing, but it was increasing in the opposite order, opposite direction. So this was decreasing, but this is increasing because it was reaching to 10, if you remember. So that's how you can write down. So 1/3 to 2 integration of velocity, and from k to 4. Why I'm using absolute value here, right? I hope you remember why it is absolute value, because the graph is below the x-axis. And if you want to find out, let's do it. So I'm gonna go, my graph is there, click on GSolve, go to the integral part, and for this you can use the mixed part, right? So if you use the first one, it will tell you from one point to another. But what was that? 1/3. So that was my value of x, and final is 2. So that is my one part, which is 11.4, and the second part is going to be GSolve again, calculate. Now I'm gonna click mixed, because what it does, it will convert your graph below the x-axis into positive area. So click on mixed and enter that q. That's correct, actually 3.42, and next is 4. Yeah, so that area is 2.6 something. So then you can add these up if they were asking you, but here they did not ask, they were asking only the expression. So we were done for this question. Let's discuss next example. If you read the velocity of an object in meter per second given by t/8 plus sine of t. So before you answer these questions, let's feed this equation into the GDC. As you can see on my GDC, I have already entered x/8 plus sine of x. Just a reminder, your calculator should be in the radian settings for angle, because it involves a trigonometric function sine of t, but there is no symbol of degrees. Therefore, it has to be in radians. So once it is done, click draw, and you can see the graph is there, but it's not same as the way we see in the diagram. So in order to adjust, you have to adjust the window. So go to window. For x minima, if you see, this is the 0, which is minima 0. Maxima is going for 15. And now go to y values. So if you see, there is not many values going down, but you can just enter -3 or 5. And highest, if you see, this is 2, so you can enter maybe 5 or 6. That will be enough. So let's go and see. Yes, it is good looking graph now. So we have very similar graph shown in the diagram. Let's read part A now. Determine the times when the object changes its direction. So if you see very carefully, it says changes direction. So guys, remember, these are maxima and minima. So where velocity is minimum or maximum, but it's not 0. Okay, velocity is 0 where? Here, 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 right? And after that it is not 0. So which means we need to find out where my velocity is changing from positive direction to negative direction. So in order to do that, I have to solve where my velocity is 0, and those are the points where I can say here my velocity was changing direction. So let's go to GSolve and find out the roots. So 1 is 0, so don't consider that because it has to be more than 0. Here you go. So 3.6097, and second point is 5.52. I have the answers. Let me confirm with the answers. So 3.6, if you go back, yes, 3.6097, correct. And next one is 5.52. Yes, so both answers are correct. So we need to solve for 0. Let me repeat why. The reason why we solved for 0 is because it says direction. They are not saying where it is turning from maxima to minima. It says changes direction. So changes direction means from above x-axis and where it is below the x-axis. So if you see, these were the 2 points where your velocity was jumping from positive direction to negative direction. So these are the roots of velocity time graph. So that was the answer for the first part. So it has to be roots. Good. Now B part, find the distance traveled when the object changes direction for the second time. So first time it changes here and second time it changes here. But they say find the distance traveled. So I'm going to go to GSolve, and here as you can see, I have a graph which is above x-axis as well as below the x-axis, right? So if you go with the first option, integral, this one, this will not allow you to calculate the total area as positive answer. It will give positive and negative because below x-axis the area is negative. So in order to solve this problem, there are two ways. Either you enter the absolute value function, or you can use this option as mixed. So click on F4, enter 0, that is the first value, right? So 0 is good, so I'm going to enter 0, and my upper enter 5.52. so as you can see here, I have area above x-axis and below x-axis, but the total area is 3.231, and that's what we got, 3.23183. So if you would have integrated, you need to use these absolute value sign so that you get your answer as positive. Otherwise, you can find out separately for the above x-axis and below x-axis, then add them up. So that was the first part. In the second part, if you see, the question says, hence determine the time taken for the object to travel 5 meters. So which means area is given and you have to find out the time. So if you read very carefully, this area is 3.23, which means in order to reach to 5, your object should travel more, right? For more time, I mean to say. So if you calculate what is the difference in 5 and 3.23, and from that point you can integrate. I'm going to show you the expression and then we can solve it in the GDC. So here is the expression. So from 5.52 to any time t and integrate, right? So when you integrate, it's t square over 16 and integration of sine is cos of t. Now plug in the upper and lower limits. The area must be 5 minus the area obtained from the first part. So how to solve this? You can use equation solver, right? But remember, you need to plug in the upper first and then minus the lower value. So I'm going to go to the equation, click on solver. So make sure you're substituting the limits in the integral form. So t square over 16. So I'm going to enter x square over 16 and then minus cos of x, because I don't have that x value, right? That's the variable we are looking for. Now minus, because this is the upper limit. Now I'm going to enter the lower limits, minus. I'm going to use the bracket because there is a minus in the second term. So here you can enter 5.52. I'm just doing as 5.2 square over 16 and then minus cos bracket 5.52, right? Close the bracket and equals to 5 minus, because 5 is the required distance, but we already traveled 3.23, therefore I'm using the limit as 5.5215. So I'm going to subtract these two. 3.23, you can enter the exact answer, but just to save time I'm going to just hit. So once you hit solve, some students make this mistake, they read this answer. That's not the correct answer. You need to go to solve. So click F6 and here you go, 7.38. Yes, we are very close. So 7.38 is the time if you calculate the total area. And how you can verify that? Go to your graph and find out. So draw, Gsolve, go to the integration, click on the mixed option. So from 0 to 7.38, right? And that should give you approximately 4.999. So it is very close to 5. So yes, so the time from 0 to 7.38, the area or the distance traveled will be 4.999. If they would have asked you displacement, so make sure you subtract the area below the x-axis. Only add above x-axis and subtract anything below the x-axis. I hope these two questions will help you. Try and practice some more questions. Thank you.